This is a Library Studio overview that will demonstrate how to use this tool to design high throughput experiments. To design a high throughput experiment, we start with designing a library, which is a set of experiments that the chemist would like to design and view the data together. To design a library, we'll start opening a new library by clicking New Design. This will open up the template where you can define the Library Studio. As you can see here at the bottom left corner, there are 5 tabs. We'll start designing the library with defining the chemicals, and then we'll define using these chemicals mixtures, and then we'll define parameters, the process parameters that we would like to use for synthesis of the material, and then we'll define a recipe to run the library. To define a library, the first thing we need to define are the chemicals that we are going to use in the recipe, and there are multiple ways we can enter the chemicals into the chemical tab. The one simplest way is to type it down. So I'm going to enter water, then you can define the molecular weight, the density, and also the type. And the type is to link all the chemicals with similar functionality together, and which we can use later on in the recipe. For example, for water, I'm going to put the type as diluent. Instead of typing it down, you can also search the chemical inventory, which is already built in, to look for a particular chemical. To do that, you can use this tab, Search Chemical Inventory, and it will pop up a query window. Here there are a couple of databases, the acid base and the solvent database. I'm going to search in the solvent database, and I'm going to search by name. You can choose other fields too. Then for comparison, I'm just going to use contains. So any chemicals that would contain propylene should come up, and I'm looking for propylene glycol, and you can see it comes up with propylene glycol, and then I can select that by clicking the propylene glycol icon, and then just use the add to source. So I'll close this window, and you can see that this particular chemical has been added to my chemical list. It also pulls out the type from the database, and that's why you see the solvent here. If you have a fixed set of chemicals that you are using to design different libraries, you can also import them from the favorite list. Here I'll show you how to create a favorite list of chemicals and then import it to your design. So I'll start with an existing design. Here this is a library designed for a lotion formulation, and we have a set of chemicals defined here. To save this set of chemicals as a favorite, I'll just use add to favorite, and here I'm going to define a new folder, and I'll call it demo, and then I'm going to select all the chemicals from this library to add to this favorite list. And just press the add button, and as you can see here, all the chemicals will be added to the demo folder. I would say OK, and then I'll go to my library that I'm designing, and here I'll copy the demo folder by dragging the demo folder onto the chemical list, and you can see here that all the chemicals would be transferred to the chemical list with all the informations like the molecular weight and the type, etc. After defining the chemicals, we can use these chemicals to make mixtures that would be used for this particular library. For example, we're going to make a mixture using the Make Mixture tab here. So when you press the tab, it opens up all the chemicals that you have defined for this particular library. So I'm going to make a mixture of propylene glycol in water. So I can pick these two chemicals and press OK, and you can see here it's going to make a solution of propylene glycol in water. Here the mixing of these two particular chemicals are considered as ideal mixing by volume. However, you have a choice to define the non-ideality of the solution by choosing a formula where you can define the non-ideal portion of the volume as a percentage of one of the components. Also, you have an option to use the known density. This would be particularly useful for if you don't have a formula to apply and you know that the mixture would be a non-ideal mixture. So after you define the density method, then you can define the concentration, and for example I'm going to define it's 1 mole per liter, and you can choose any units from this drop down list like mass percent or milligram per milliliter, etc. So this is one way of defining mixture. Of course, you can have the mixture previously defined in your favorite folder, where you can just drag and drop, and it will take the mixture that you have used before, and most likely you want to use it for multiple libraries, and it will, as you can see, it can also bring in all the concentration information along with it. Also, there is another way to make this mixture is basically to just drag and drop chemicals from the list of chemicals that show up here in the top left corner. For example, I'll make a stearic acid solution, so I'll drop the stearic acid into the drop down box here, and then I will choose say water as my solvent. So once I bring water into the box here, you can see it will be a stearic acid solution in water, and again you can define the concentration here. So after you have defined your chemicals and the mixture that you are going to use for the library design, the next step is to define the parameters that you'd use to define the processes that you want to run on the library plate to generate the data that you desire. So to do that, there are you can name a parameter by putting down the name in the name list. For example, I'm going to generate a parameter called stir temperature here. So let's just type down the name. So I'll put stir temperature, and then it will ask what kind of parameter is it. So it will give you option from the drop down list. So it could be a number, it could be a rate if it is a stir rate, as you can see at the top. So for this one I'm going to choose temperature, and of course you, for the users, so that whoever is designing the library have an idea what this temperature mean, you can put description here, and for example I'm going to put stir temperature. Also, you have option here to define the property for this particular parameter. For example, you can go to the property tab, and you can open up the window where you have the option to define the properties, which for the temperature, it's the unit, it will have 2 decimal places. Then you can define, okay, the minimum would be close to room temperature. So when you are designing the library, if the lowest temperature it will take is 25°C, and also the maximum temperature you can define, for example, 200°C, because maybe some of the volatile stuff in the library would evaporate if the temperature is higher. And then also you can relate this parameter with the other parameters or other variables that you have defined before. I'll give an example here. So you can say that the store temperature would be 25 degrees higher than the blender temperature. So what you could do here is I can say that select a source. So it says we have a lot of items in the source. So, and then you can basically choose the parameter, say blender temperature weight, and then I can say just set this temperature 25 degrees higher than whatever is the blender temperature defined. And if you say okay, it will basically link this particular parameter to parameter 3, and it would be calculated by default. So these parameters are actually the process steps, as you can see here: stir rate, blend rate, blending temperature, or wait time when you are blending, measuring pH, or weighing the vial, measuring viscosity, etc., which are basically mapped to the library. And then these parameters are read by the Automation Studio software, which basically execute a particular physical step to create the data that you want to get from this library.